I'm Anil Kumar, and in these set of videos we are trying to understand how to do problem solving using quadratic equations. The question here is, the length of a rectangle is 16 centimeters greater than its width. The area is 35 meters square. Find the dimensions of the rectangle to the nearest hundredth of a meter. So first thing is, whenever there is a word problem, make a diagram to represent the situation. Now in this particular case, we are given that the length of the rectangle is 16 centimeters greater than its width. So let's define width. Say let width be W, and you can say and length be L. Now in this case, we are given length of the rectangle is 16 centimeter greater than width. That means length is equals to width plus 16, correct? So we can write here width for width W, and length we can write as W plus 16, correct? Now it says that the area is 35 meters square. So area equals to 35 meters square. Find the dimensions of the rectangle to the nearest hundredth. Now since we need answer to the nearest hundredth, that means we have to use quadratic formula, right? So don't even try to do factoring for this particular question. Now area is length times width. We know length is W plus 16. Multiply that by width. Area is given to us as 35 meters square. So let's write 35 here is equal to, and let's expand this. We get width square plus 16 W. Now to find W, we can bring all the terms to one side. So we get W square plus 16W minus 35 is all equal to 0. Now let's use the quadratic formula, right? So quadratic formula is, let me write the quadratic formula here. So width W will be equals to minus of B value, which is minus 16 plus minus square root of B square, which is 16 square minus 4. A is 1 times C is minus 35, right? Square root divided by 2 times A, which is 1. So that's your quadratic formula. Now we can use the calculator. Remember, minus and minus will make it plus, right? So let's calculate what is there within the square root. So within the square root, we have 16 square. Let me write plus here, 4 times 35, and that gives us 6 square root 11. In decimals, 19.899. So we get 16 plus minus 19.899 divided by 2, correct? So that becomes the possible width. Now there are two combinations here. One is we could take away 19.899, but that will result into a negative number. Now width cannot be negative, right? Therefore, we have to add, right? So the other option is to add. So from here, we get width as equals to the only possible solution, which is 16 plus 19.899 divided by 2. So let's use the calculator once again. So we already have 19.899, take away 16 equals to, divided by 2 equals to, let's write it in decimals, which is 1.949. Now the question is, we have to write dimensions to nearest hundredth of a meter. So hundredth will mean this position, which means 1.95 meters. So that's the width for us. If width is 1.95 meters, in that case, length is going to be 16 plus 1.95, that is 17.95 meters. So the dimensions are, that is our answer. Length is 17.95 meters by 1.95 meters. So that is how we can solve this question. So for a given word problem, try to sketch a diagram, define your variables, read statements to form equations, relate one variable in terms to the other. Once you have an equation, then solve it using the known techniques. Thank you and all the best.